What I do here is developing a new tool to assess anxiety-like and depressive-like behavior in rodents in order to understand the underlying mechanisms of chronic stress exposure and how it changes either behavior but also molecular and cellular pathology to mimic the human depression. My name is Thomas Prévost. I'm a postdoctoral fellow here at the University of Toronto, and I work in the field of preclinical neuroscience. Right now, we are working on something very important for our group, is to make sure that we can assess anxiety-like and depressive-like behavior in a very reliable way. Because right now it's very difficult to repeat the assessment in mice models for anxiety and depression, because most of the time tests like the elevated plus maze, the open field, or the force swim test, in mice it's not possible to repeat them multiple times. What we did is, using the phenotype boxes, we put the animals overnight, and then we shine a light inside the box in the middle of the night to induce an acute stress. And with that tool, we would be able to assess anxiety-like behavior and the trajectory of anxiety-like behavior every week in the same animals. Our research has multiple levels. So the first thing is that we want to understand the underlying mechanisms, because by understanding the underlying mechanism for anxiety-like behavior and depressive-like behavior, we can target those mechanisms in order to develop new therapeutics. So what we want to do using the phenotype boxes is to understand how chronic stress can induce depressive-like and anxiety-like behaviors, and how these behaviors are related to the cellular and molecular pathology. And by doing so, we can identify potential new targets to develop new therapeutics that will have a good effect in our animal model, that will alleviate the anxiety-like and depressive-like behavior first in rodent, and that will be demonstrated using the phenotype boxes. And if this is successful, we can bring those new therapeutics to human, because potentially if they work in rodents, potentially they can be beneficial also for the human pathology.